Well, hi, good morning, and thanks so much for joining me in my shop here for another day, or at least another hour on this radio. Just before I get going, let me just talk about the psychology of the situation here. If you do this kind of work, you'll find yourself in the same boat I'm in right now, which is I've worked very hard to try to solve a problem. I haven't managed to solve it. In fact, I really haven't gotten anywhere with it. That's quite a few hours of work, and for you as a viewer, it's quite a few hours of viewing me not get anywhere. Each day it gets a little harder to come in here and continue to work on it. I think it's a very natural response. Human beings don't like pain, and we also don't like to think. Did you know that? Human beings don't like to think much, and this is forcing me to do a lot of thinking here. So what I do to try to keep my spirit up is I cut the work off when I think it's becoming too much, and you see me do that in videos right towards the end. Sometimes I'll comment, well, that's enough. I'm trying to not go over the edge. And another thing I do is I try to keep hope alive. I try to always have something in mind that is down the road that I can look into, so I have something in my back pocket that can keep hope alive even as I work on other issues. And there's a couple of them in here. And as you work your way through something like this and you're eliminating things, there's lots of stuff to eliminate. It takes time to get all the way through them. So there's a couple here I'm going to do today. Let me back up just a little bit. I've sort of reached the conclusion that this radio is properly wired, that there is no component error anywhere in it, and it is doing what it's doing for some kind of subtle reason, I guess. I'm not sure what the right word is, but it's not doing what it's doing because something is out of order in terms of components and things like that. I could be wrong about that. It could easily be some ground that's not making contact or something that I haven't discovered yet. But at this point, I'm going to go on the basis that the radio is actually wired properly. All the components are working properly. It is a radio at this point that is designed to motorboat. That's why I'm going to approach it. No, of course it's not actually designed to motorboat. So I want to thank a person for sending me an article. We're going to take just a quick peek at it. It's one of these lovely old articles that's I find just wonderful to read. I think it's a little booklet or something like that. Let's take a peek at it. So here it is. It's on a website called CanadianVintageRadio.com. I'll have to look into that a little further. So thank you very much for sending me this. I hadn't noticed it's actually a Canadian website. Check out this book, How to Make Extra Money Fixing Radios. It's an American book. And here's number 23, How to Fix a Receiver That Squeals and Motorboats. You could put an or in here. These things can be quite different. The motorboating and the squealing can be quite different sort of things. So we're not going to go through this. I'm just going to let you glance at it. This is a long article, really well written. Goes into all the aspects using lots and lots of words. Fantastic. And this is sort of helped me to focus down on a couple of things, but let's look at this last page here. I think this last page kind of tells it. Let me make it a little bigger and we'll just go down. It's very quick. Common causes of oscillation. These causes of oscillation are listed according to the symptoms they produce, with the most common first. Oscillation, audible whether or not a station is tuned in and regardless of position of volume control. The defect is in the audio stages. Okay, so we're going to look at that. Even though it says regardless of the position of the volume control. In this radio, the volume control needs to be turned down to trigger the oscillations. That's not really what they're getting at here. What they're getting at here is if you can turn the volume down and the oscillations disappear, then, I shouldn't talk so much. Let's just keep reading here. Yeah, I'm talking too much. Read, man. Oscillation audible whether or not a station is tuned in, but affected by position of volume control. The defect may be in the IF stages, in the second detector or the first AF amplifier. Possibilities: open filter or bypass condensers, This is the one we're going to dwell on here. Bypass condensers, shielding missing, making poor contact, alignment off. The alignment could be off, but I don't think it's causing the motorboating isn't going to come from that. Squealing might. Excessive screen grid voltage. Leads improperly placed. Oh no. I have moved lots of wires around in this radio, and I've been trying to unmove a few of them most recently. Oscillation audible only when a station's tuned in. No. Oscillation audible only when a station's tuned in. No. So it's got to be one of these two here. They're kind of suggesting it's in the audio section of the radio. There we go. Anyway, I thought that might be interesting. Now let's go to the radio. So in this radio, I'm going to show this just on paper quickly. There is a critical capacitor whose job is to eliminate motorboating. Now, I didn't really appreciate this so much. In this radio, that capacitor is right there. Oh, no it isn't. That capacitor is right there. That is C36. Okay, C36 is the 4 microfarad capacitor. I had a little trouble reading this because I'm old. That's why. So that 4, which is sitting here, okay, if you look carefully, the draftsman was a little lazy and he drew these capacitors to the nearest grounded wire. So actually the bottom of this capacitor is tied to the negative bus. Top of it is between this resistor and this resistor. That's 11 and 12. That's a voltage divider of some sort. R11 and 12. 11 is 22K, 12 is 220K. That's a suspicious 1:10 ratio, isn't it? So apparently you can develop feedback and oscillations because of failure to eliminate small feedback voltages from getting to the grid, either of the output tube or even back to here. And this guy is supposed to take care of that. You know, it's a 4. Maybe it needs to be a 10. The fact that it's a 4 microfarad capacitor is really weird. You don't normally find, at least I not in my experience, a large capacitor in this position. Those large electrolytic capacitors are almost always, you know, the filter capacitors in the power supply or a bypass capacitor. It's not too often you find one kind of just out there. So that already indicates to me that they couldn't get away with just a kind of a regular 0.01 or something like that. It put a great big 4 microfarad capacitor here. So there's problems with their design in snuffing out whatever it is they're trying to snuff out at this point. So that's something we need to look more closely at. That capacitor is, I could be wrong, is this one. Maybe it's this one, doesn't matter. It's one of these two. I think it's this one. The second thing is, in a lot of radios, the AC signal path back to the negative bus is through the filter capacitors in the power supply. They're fairly large electrolytic capacitors. You know, they're up here on this schematic. The draftsman or the engineer drew them up here. Usually they're drawn down by the power, like, well, anyway, don't talk. Keep going, Jim, keep going. So, these capacitors are really good at filtering 60 hertz, and that's why they eliminate the hum in the power supply. But they're not very good at higher frequencies, especially RF frequencies and the like. So one solution is to simply put a bypass capacitor across the filter capacitor. So you put in a typical, like a 0.05 or something like that, across them, and then the RF will find ground through those capacitors instead of trying to find it through the filter capacitors. If the filter capacitors are developing a little bit of RF voltage across them, if they're not snuffing it to 0, if there's a little voltage setting there, that voltage is on its way and signals on its way back in the radio to come around find some sensitive grid somewhere and come shooting out again. So there's two possibilities that I'm talking about. One is this motor ender capacitor, which may not be working properly, or the filter capacitors, which incidentally are not original. I've replaced them. Here's the replacements. They're brand new, but I don't think that guarantees in any way that they're going to work at RF the way they need to in this radio. So it could be by replacing these, I actually introduced the problem. Solution is really simple and easy to prove with my now favorite new tool, the snuffer. By the way, this thing, which I just kind of dreamed up, I was going to sleep the other night just thinking about stuff. I thought, why don't I do that? It turns out this is written up in the article I was just reading. Thank you again to I think I can say BT. I can't remember the initials of the person who sent it to me. Shameful of me. How can that be? So I will remind myself here very quickly. BT, yeah, BT. You know who you are. Thank you very much. Now, first thing we can try is turn the radio on, and I will try applying extra capacitance to these critical spots. Now, this doesn't add much to 0.04, but let's see. Let's see what happens. And you know, maybe that's going to identify the problem. The problem is actually a design problem at that point, or at least maybe we could put it this way: the design was good 70 years ago, but if they'd only stopped and thought about what was going to happen after this radio's been around for 70 years, they might have done something differently in there. Okay, full power. Where's the wump wump? So first one I'm going to try the power supply capacitors. Two down here. I'm going to bridge one as soon as I can figure out where to do that. Follow this red wire up to here. Does this kill it? Do a thing. I think we're off on the wrong track. Now there's another capacitor here with its own positive wire, and that's going, where's that going? Oh, it's way in the corner. I think, I can't really tell for sure. There's a bunch of red wires right here. Hey! That was exciting. That was really exciting. You notice I have an automatic quick release on this. And you couldn't tell, but I was halfway out the door already. Woo! That was exciting. I'm gonna try that again. I gotta calm myself down now. Okay, so that didn't get anywhere. So we will now try these other two little capacitors here, one of them anyway. This guy. I'm scared now. Did it blow the end off my wire? No. Well, it doesn't do a thing. And the other one I'm quite certain won't do anything either. Is there anything left of my capacitor? Let's kill the signal where we know we can kill it. Whoa! I'm feeling reckless today. Yeah, it's still there. Okay. Okay, so I managed to try 0.05 bypass on the power supply capacitors. No effect. On either one of those two, no effect. One is a bypass for the output to cathode resistor. The other one is this snuffer. So how come? I'm going to fool with this snuffer one a little more here. That's this one here. Let's just double check that. It's Exciting now. Every time I put this in the radio, I'm ready for a big explosion. Very exciting. Nothing happening whatsoever. Those theories went down the drain pretty quick. So I am adding a tiny little amount of capacitance to this 4 microfarad, so maybe that's why it's not having any effect. What if I put a big whopper in here? I'll parallel the 4 with, I don't know, a 10 or something like that. What kind of voltage is on this? B+. Yeah, I'm going to put a bigger capacitor in here. I'll just do it kind of temporarily. How fast can I do it? So we want let's see, how big is this guy? This is a 10 at 350 volts. Let's try this. It's just a temporary thing. Turn the radio off, put this on, and then turn the radio back on. Okay, power off. And for sure, is this get that off there. And for sure, this goes to ground, goes to the negative bus. Woo, 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 woo. Wait a sec, Jim, check. Yeah, negative bus onto the chassis. Yeah, everything's been done to the chassis so far. Put the right one on the chassis. So we don't have... I've had enough excitement for today already. Positive one, go on the positive lead of the capacitor. We're doubling up. So we're tripleizing it. Triplize it. Okay, even with all these wires hanging out, what happens now? I didn't change the volume control, so it should just come back putting away. Put away. Well, there it is. Now, did this change it at all? The situation's getting worse and worse for me, I think. Like 80% of the volume control is involved with this now. Okay, so what does this do? I will disconnect it. Didn't do anything at all. Not even nothing. Not even nothing. Okay, so we're running out of ideas here already. Going back into the zone here. What's in my back pocket? That stuff I just took out was in my back pocket. I have nothing back there now. I have nothing back there. So when it came to snuffing this thing, it seemed to me that this was going to help find the bad guy. Pull this out of here. Okay. So we're going to go snuffing some more. What I did last time in snuffing stuff, I wasn't really thinking much. I was just doing it to see what would happen. I was quite happy with what I was able to do with it. Now I got to be a little more scientific with it. I think that's the name of the game. So, and there was a little bit of confusion about tubes and stuff like that. So we found we snuff it entirely when we go at the grid of the output tube, obviously. What do you get on the plate of the output tube? Plate of the output tube. Okay, here we go. 6v6. Yes, you'd think I'd write all this down and I wouldn't have to look in the book all the time, but no. 6v6 plate 3. Plate 3 screen. You know, we should investigate the screen an awful lot here. 4. 3 plate 4 screen. 3 plate. Output tube there. 3 plate. Just looking for the key. There it is. I see it. So 3. Well, of course, the 2000 volt capacitor is on the plate of that. Certainly changes it. What if I go on the other side of that capacitor? That's the other plate. Wow! So that point I'm touching there, there's a resistor. It comes from it over to here, and then a resistor goes from there back somewhere. Those are the two 22K and 220K resistors, and that is the drain capacitor. Nothing, but on the other side over here, what happened? How come it's not doing it now? What happened? What happened? Come on. What happened? I'm just getting something good and then it disappears. What's back down here? You know what? I think this ground connection's unreliable. Let me put it on a more reliable place. Yeah, right by the power capacitors. No, let's find an even better spot. A really good one right here. Okay, here we go again. Okay, this is the plate. Yeah, that's what it was. Bad connection here. So now we go to the other side of the resistor where the killer cap actually is. The little guy's not doing anything, this big guy's not doing anything. I checked those resistors. They measured correctly. I'm going to check them again. I'm going to check them again. First, we're just going to look to make sure there's no voltage hanging around there. There's a big capacitor hooked up to them. Let's do it the other way around. Anything here? Curious why that would just be rising. You know, you'd think voltages are draining out of the set. 3 big volts there, and over here can't very well be measuring the resistance here with this sitting here. Can try knocking it out. Okay, a clip on there, and then just stick this on the ground. A nice ground. Here's one here. Come on. I guess that's why I don't use this particular clip lead very much. Okay, I'm going to give that a minute or two. See if we can't drain out all the charges in the radio. So again, here's the voltage divider we're checking. Resistor here, resistor here. This is the B plus line at the top. You see each feed coming off B plus. Oh, it's not true. I was going to say each feed has a resistor. There's no resistor there, no resistor there, resistor here, resistor here. They did not. So the resistor provides a little bit of isolation. There's nothing here. And that's the plate, and straight wire, straight connection to the screen of this tube. They're intimately connected. Now wait a minute. It's really hard to see. There's a capacitor here and a resistor to the ground here. It's complicated to look at, but that's a little surprising to me. There's nothing kind of in between these. Okay, enough. We've passed enough time now. Let's see what we got here. Take this guy off. Pull this off too. Did we kill all the voltage? Probably not. Yeah, looks good. That's there, and then over here. Now still a little bit there. It can take a long time to really get rid of all this. Well, let's try. I have the feeling you can't do this. You can't take a resistance reading. So we want to see a 22K and 22K and 220K. So I think this is bogus. We're going to go here. Well, wouldn't that be? That's about 200, isn't it? God, stay on there. About 200K on that one. And so if that's the 200, the other one is the 22. That's this one. And there's the 20. 26 versus. So one's gone high, the other's gone low. But I'm testing them in the circuit. So the fact that it reads low. Is it the resistor? Resistors tend to go high. We're reading across, oh boy, we're reading across 12, I think. 12 to 20. Okay. 12 and oh, well. Well, there's a capacitor there blocking. This comes to a plate, so there can't be anything happening here with the resistance measurement. The other side goes to a plate, a capacitor, and a capacitor. So again, so I should be reading the real resistance across 12. 12 low. Maybe that's the problem. These two resistors, one has gone low and one has gone high, and the combination has upset the filter here. Since I have absolutely nothing else to go on, we'll have to fiddle with this. What easy thing can I do before replacing them? Because they're awkward to work on in there. I think what I'm going to do is I'm going to drink some coffee, ponder my situation before I get in there and mess things up worse. Okay, resistors are out. Let's check them. This is red, red, orange. Oh! Wow, that's a lot of corrosion under there. So sometimes rubber materials, this isn't rubber though, or I don't really know what it is, to be honest with you. Rubber materials can contain, and other things like this can contain volatile components that come off, gas off, and can do stuff like that, I guess. Wow, let's look at this, both wires. What about under here? Same kind of deal. That's probably happening throughout this radio from these rubber guys. Okay, still do a test. So this one is the red, yellow. What do you tell us? That's what I got when I checked it. 200. It's supposed to be 220. What's that? That's the 10%. 20 and 200 is 10%. It's not very far off. Really. So he is high. So the tests were valid. So you're supposed to be 22, 26, and the other one's supposed to be 22, 20. Well, in a world where you don't know what else to do, this makes sense to do here. So I'm going to install 2 new resistors there, and one of them's a little larger than the other one, A little higher wattage on one of them. Maybe I'll just check that in the listing before I do it. Okay, since precision seems to be important here, maybe here's a precision 22K resistor. How precise? How precise is my meter? Well, that's 22, all right. Okay, that's good. And then this one is the 220. It also has a gold band. 220. A touch low, if you believe my meter. Okay, those will do though. I will install those guys. Hope your fingers are crossed. Okay, I think I got them in there. Let's just check. Okay. And no shorts in there. Good. Okay, we're ready for a try. Put your money down on this one. Okay, this one I give... Wow. I don't know if I even want to bet on this one. There we go. Dim bulbs first. No difference. So the volume control is actually working quite well if it wasn't for the nonsense. There we are. Well, it's another day done. More shots taken. Failure is the result. But not really. Every step forward, I'm getting a step closer to finding it. That's right. Just 16 million steps to go. Hey, see you on the next video.